Okay, we're getting ready to start Chapter 3, Exponential and Logarithmic Functions. And the very first topic in Section 3.1 is on inverse functions. Now, in algebra and in arithmetic, we have inverse. We have inverse operations in arithmetic, such as adding and subtracting are inverses, multiplying and dividing are inverses, inverse operations. Well, we also have inverse functions in algebra. And when we take functions and we compose them, because the operation that we use is not adding, subtracting, multiplying, or dividing, but composition, and we get to the identity, that's when we're talking about functions that can be considered inverse functions. But I get ahead of myself a little bit, because not all functions have inverse functions. Only what we call one-to-one functions have inverse functions. And you can see the definition up there that a function f is one-to-one if for a and b in the domain of f, and a does not equal b, then f of a does not equal f of b. So what that kind of says is we know with a function we can't repeat our x's and have different y's. Well, in one-to-one functions we can't repeat our y's as well. So another way to state this a little bit more directly is that if f of a equals f of b, then a has to equal b. The only time the y values are the same is if the x values are the same. Now graphically, we know that when we're trying to determine if the graph of a relation is a function, we use the vertical line test. Well, to see if it's a one-to-one function, we use what we call a horizontal line test. No one-to-one function will have two or more points that are aligned horizontally, and here's the actual test. A function defined by y equals f of x is one-to-one function if no horizontal line intersects the graph in more than one point. So we're going to use this and this to answer some questions over here. Determine whether the function, and it's defined by a set of ordered pairs, is one-to-one. Where you can see that it is a function that all the x values are different. But is it a one-to-one function? Well, all the y values have to be different. And they are. So yes, this one is a one-to-one function. Down here, this is a function, all the x values are different. But as you can see right here, this is not a one-to-one function because these two x's, which are different, have the same y, and that can't happen. It's not one-to-one. It's still a function, it's just not a one-to-one function. And therefore, since it's not a one-to-one function, it doesn't have an inverse function. Now let's look at sketches here. We have three that are graphed. You'll notice here that this passes the vertical line test. This one is a function. This does not pass the vertical line test. This one is not a function. And this one is a function because it passes the vertical line test. But are these two guys one-to-one? Well, this one I'd have to say no. Because if I draw a horizontal line like this one, it crosses it in a bunch of points. So it is a function, not one-to-one. Over here, this one is not a function. But you can see that this relation is one-to-one. Not that we would have to have one-to-one for a relation here, but I'm just looking at it. This passes the horizontal line test. No matter where I draw a horizontal line, it crosses it no more than one time. So this one is one-to-one. Over here, you may recognize this. This looks a little bit like one of the like a translation of the square root function. This is a function. It passes the vertical line test, so it is a function. And it passes the horizontal line test. I can never cross this graph more than one time with a horizontal line, so it's one-to-one as well. So only this guy here would have what we call an inverse function. Now, I'm going to show you how to find an inverse function, but I'm going to show you how by definition you can tell whether or not, without being given a graph or without being given a set of ordered points, but given the rule, the equation how to determine if it's 1 to 1. Now, students don't like this because this is a little bit like a proof. But what you're going to do here is you're going to go to here. If f of a equals f of b, then a equals b. So f of a equals f of b. That would mean negative 4a plus 1 equals negative 4b plus 1. If I subtract 1 from both sides, that means I get negative 4a is equal to negative 4b. And if I divide both sides by negative 4, I get a, that a is equal to b. Now I started here with this hypothesis and I got this conclusion. So therefore, this is 1 to 1. Notice here how I set this up. I set f of a equal to f of b, and I solved it by substituting in and hoping that I get to this statement here at the end. Let's try it with this guy. Let's see if he's 1 to 1. So f of a would be absolute value of a minus 3. F of b would be the absolute value of b minus 3. Now if I add 3 to both sides, I get that the absolute value of a is equal to the absolute value of b. Well, does that mean a equals b? No, because of the absolute value, that means a is equal to plus or minus b. And that means that this is not 1 to 1. So use this right here when they give you a function and they ask for you to determine whether when they give you the function as a rule, like I did in parts A and B here at the bottom, and they ask to see if it's 1 to 1 or not.